Hello, everyone. My name is Angela DeStasio from the Garobi marketing team. Welcome, and thank you for joining us for this webinar today. Ready, Set, Optimize, Building the Business Case and Securing Buy-in for Optimization Projects. Today, our featured speakers are Steve Sashihara, CEO of Princeton Consultants, and Jerry Yurchison, Data Science Strategist at Garobi. Here is the agenda. So I am going to pass it over to Steve to get started with building the business case.
Hey, welcome everyone. I'm really pleased to be able to present to you. My name's Steve Sashihara, and the principal hat I'm wearing is as the CEO of Princeton Consultants. We've been doing optimization work under various names, and I'll talk about that a little bit in my presentation. The last 43 years. Um, I've been a very enthusiastic supporter of the use of optimization as a primary business tool. In 2011, I published a book called The Optimization Edge, written for business people. And this talk is in the same spirit. It is not a technical discussion as much as it is a business presentation of optimization. I would like to acknowledge and really jump into the context of optimization in business by noting that my book in 2011 was really built on the demand created 4 or 5 years earlier by Tom Davenport, who brilliantly wrote this book called Competing on Analytics for the Harvard Business Press, and really single-handedly got everyone talking about the term analytics. If you haven't read his book, it's terrific. He also has a Harvard Business version of it, a shortened version, which is great for executives. I wanted to point out that this is the diagram from the very, very first page of his book, Competing on Analytics, where he says, if you want to really get it down to one picture, this is what analytics are. It's these 8 things, and they are of increasing value and competitive advantage. And if you look at it, you'll notice that optimization is at the very top of the stack. And so that got people asking the question in the business context is, what is this optimization stuff? And that's one of the things that allowed me to publish my book and to get people in the business side, not just the technical side, talking about this. Tom Davenport, in addition to being the spokesperson for analytics, also rode the wave as it really changed into, I would say, more from being analytics to data science. My personal view is that the two terms are roughly equivalent. Wonderfully, Tom wrote a piece also in HBR in 2012 that said the data scientist is the sexiest job of the 21st century, which I think is wonderful. And I think that if we, that was 2012, I think that we can all say that the hottest story in the last year has been the explosive interest in AI. And I just want to basically use those 3 to context the way we at Princeton view these 3. We think of optimization as not in opposition to or as an alternative to AI. We actually think of it as a subset of AI. And we think of AI as a subset of analytics or data science. So data science analytics is the examination of data, some of which is actually used to automate intellectual tasks, i.e. AI, but not all AI is optimization. Some wonderful, brilliant AI to discern, for example, is this a picture of a person? Is this a picture of a cat? That's not particularly optimization. It's brilliant, it's smart, it's interesting, but it's not optimization. Optimization requires a system that will make recommendations for action. And that's basically what differentiates optimization. So today, our presentation, our discussion is about how to build a business case and securing buy-in for optimization in a corporation. Just a quick slide to explain what we mean when we say optimization. It's not in opposition to mathematical optimization, but this is sort of a business presentation version of it. So you start with assets, and you'll notice I use a little square quotes around assets to mean, I don't mean assets necessarily in the strict economic sense. I just mean things of value that you have some control over. So for example, your employees do not show on your balance sheet, but you have some control over them, and they are assets that you're trying to maximize the value. In addition, your customers, your shoppers, materials, all these things are assets. Then you have decision classes that you're making about them. And what optimization is one or more of the assets and one or more of the decisions. And you're doing this to basically create business outcomes: efficiency, effectiveness, nimbleness, consistency, profitability. So in one slide, that's kind of an introduction to optimization from a business point of view. What decisions are we making about things of value that we have control over? I just want to say somewhat rhetorically, if optimization is so powerful, why do execs need convincing to invest in it? In other words, why is this talk necessary? And I want to give you, two reasons, I think. One is that execs are constantly being pitched, both by internal and external people to spend money on this, spend money on that. And also, I think one of the problems with optimization is it's a word everyone loves. And so a lot of things that are called optimization, like I know I'm being a little bit funny here, but this is optimal solutions, hair, skin, nails, gummies from Nature's Bounty. And for you guys, this is optimal carnivore. um, uh, Books on optimization, how to lose weight and be healthy, how to optimize your finances. And so A, execs are constantly being pitched, and B, our word optimization, optimize, is an English word and is often appropriate for something good that you want. But I think the second and more important reason why optimization needs to be um, uh, pitched and sold to the all the way up to the C-level, and the purpose of this presentation is because the execs learn to say no to anything that isn't basically focused on accomplishing their business strategy. So there might be a lot of good things that they should be doing, but they really have been trained. You've got to focus on things that are aligned with your business strategy, which I think begs the question, what is strategy and how to align the business with it? So with your permission, I'd like to just do a real quick thing on strategy, and I'd like to um, give a shout out to one of the people I think is the clearest and most straightforward writer on strategy, a guy named Roger Martin. Here's a little of his bio, and he's written, I believe, 13 books. If I had to pick out one that I think is a great, possibly his best book, it's Playing to Win: How Strategy Really Works. And I just want to say it's a terrific book. He co-wrote it with the CEO of Procter and Gamble, and it's a terrifically written book. And I want to use basically the heart of the book to kind of launch into what we're about to talk about. According to Roger, business strategy can be simply stated: here are five, what he calls a cascade of five questions you want to ask in order. What does it mean to win? Where are we going to play? How are we going to win? What capabilities must we have? And what management systems are required? And optimization can enable strategic winning, particularly in the bottom three. I would like to say, when you do an optimization model, a lot of times I have found, maybe you found the same thing, you go into an organization and you'll be putting in what might be their first optimization model, and you need to come up with an objective function, and people kind of hand wave at what they're trying to accomplish. So even the first step, what does it mean to win? Um, Optimization brings a really good vocabulary to trying to take something from a vague science, vague art, pardon me, to a specific science. But I think we're really hardcore value add in how will we win? Is it low cost? Is it differentiation? Is it both? What specific capabilities support our competitive advantage? As I'll show, our decision space, and what management systems are required. Um, I think getting a little bit more into Martin, he says basically good strategy is about making explicit choices to increase the odds of success by insisting on creative and rigorous approach to exploration and testing. And that is really, quite agree, that's really the motivation behind doing formal business cases when you have an optimization project. We at Prince Consultants have reduced this to a five-step formula that we use for our own projects. I'm going to walk you through one of our cases, obfuscated, to kind of illustrate this. But there are five steps that we believe are valuable, necessary to earn buy-in for an optimization project from the C-suite. So starting with the first one, What we believe you should start by doing is analyzing the flow of information decisions to the organization. We don't start with a model. We start with saying, how does information flow through the organization and what decisions are being made? I'm going to show a slide here that walks through a basic case. I showed this to a colleague last week, and he said, "Wow, this is really specific. This is really down in the weeds." So I'm not trying to teach what these little diagrams mean, just to maybe give you a view of it. But I just want to say, um, I said to him, "Mike, good, because all the diagrams that work are very specific to the business, and someone in the business should understand what each little box means, but someone outside the business wouldn't have a clue. But regardless of how specific or how domain specific it is, usually you want to start from the top down to anchor the analysis. So you don't need any special knowledge of a business to know what revenues, service, and costs are, and their desire to achieve profitable growth. So stepping into a little bit of the weeds of this particular project, um, these little rectangles are decision blocks, and the ovals are uncertainties. This is called influence diagram. And so to the business that we were working for, a large transportation company, they knew exactly what these four boxes meant. They knew the difference between contract and spot pricing, what load acceptance was, and what planning execution is. So the purpose of this presentation isn't to explain that, but maybe give you some context. So the first thing we do is we start, what are the key decision areas? And I'll explain why I'm using the word area rather than just saying the key decisions, because each of these is really, to an outsider, maybe one decision. Load acceptance, do we take it or don't we? But to an insider, there are lots of little decisions that are being made inside it. Secondly, we want to say the outcome that we're trying to achieve is not completely under our control. So we may have complete control of our own decisions, but there are other influencing factors that are impacting the decisions we're making and the outcomes. And those in this diagram are uncertainties. So, for example, in this illustration, the overall customer demand and competitor actions are not under our control. They're somewhat uncertain to us. They may involve purposeful obfuscation. The competitor isn't revealing what they're doing to their competitors. It might require forecasting. And so we need to basically analyze both the uncertainties and also look at the decision making. Here's a tip. You really want to complete the entire picture. So typically there are revenues and services you're trying to maximize, but also there are costs that you want to minimize. And often the costs are complicated and you're really getting into the weeds of how things work. In this particular case, lots of domain-specific ovals, but everyone in the business would understand we know exactly what these mean and they're complicated. So step one, analyze the flow of information and decisions in the domain. I just want to point out that the ovals, the uncertainties, are great machine learning, data science opportunities, and the decisions are great optimization opportunities at a first approximation. So we're not competing for the same turf largely. The machine learning and data science are terrific at saying, hey, let's get a better way of forecasting which loads will get booked, what the competitors are doing, what the overall customer demand is. And we as optimizers are good at saying, thanks for that information. We'll help permutate the different possibilities, score each one, and give you what we recommend as the best outcome. The next two steps are to identify key decision areas to start with, and then to dive in and look at them. And by look at them, we mean, what's the status quo look like? So recall this diagram. In this particular instance, we picked one specific area called load acceptance. And I think what this illustrates is that you always want to do this, we think, in the context of a bigger picture. So you would say to an executive, having walked you now through this flow, here's the area that we believe is got the lowest hanging fruit, is the one that we should dive into first. And ideally, it's an area that management has already said we want to focus on that. So other areas may have other initiatives going. There might be skepticism about whether there's a lot of upside value there. So it's really helpful if they say, no, we believe, talking among ourselves, looking at what others are doing, we believe that we want to pick this area, in this case, load acceptance, as an area that we want to see whether we can, move the needle with. The third step then is to collect data and model the status quo. I just want to say as a tip that what from the outside often looks like a very simple decision, from the inside is often multi-step and complex. So to an outsider, load acceptance in this transportation company is, hey, a customer calls and offers you a load. Do you want to take it? Yes or no? How hard can that be? Well, let me show you this. So this is obfuscated, but this is some of the work product that came from the project team. Here are all the steps and data requirements that are within that box. So we don't say yes unless we think we can do it. And we also don't say yes and think it's good for us. We also have to decide, what have we promised our customer? What have we done to date? So there's a lot going into yes or no. And so my point is, if you are going to build a model in this space, the load acceptance space, you better get your details right, and you should model them with actual historical data. So step 3, collect data and model the status quo. Now comes the fun part. So step 4, you say, okay, now that we've established from the top down, we have established an area to focus on. We have established the status quo. We've modeled it rigorously with data. Now it's time to build a model, an optimization model, and compete against the status quo. I know a lot of the people on this call are deeply interested in this subject. I just want to mention that Jerry Jurchensen will be talking about a bunch of Gurobi resources that they've collected. I know that they're always very helpful on how to actually build these. So I'll skip over this step here. And of course, it's of deep and great interest. But one builds an optimization model. I'd like to just talk about end up with what you do once you've built that model. So the last step after you've built the model and compared it is you want to create a formal business case. So if you say, hey, I found an area, we found the status quo, I create a model and it works. Am I done? Can I go yay? No, you are not done. Step 5, congratulations, it's wonderful. But step 5 is now you've got to translate your win into the language of business. And the language of business is finance. So you need to build a formal business case that shows what are the categories of benefit, what are the savings, what are the financial, what are the dollars and cents. Why should an executive approve funding the deployment, the rollout, the scale up of your optimization model? You need to create a formal business case. So the first thing that we recommend you do is once again start from the top down. So these are very specific to this particular application. Don't expect most people to understand these, but the people reading that did. So if we said we are going to reduce empty miles, they know exactly what that means if they're in a transportation company. But what we start by doing is saying, here are the categories of improvement before we start getting into the pure analysis. And I'll show a little bit of a conclusion slide. I'll just pick one, the first one, R1. It's helpful sometimes to put them in the order where the most important, the biggest impact ones are at the top, just how people tend to read things. So it turned out that increasing revenue per load was the primary driver. But having organized this now, you can see probably the presentation is going to be the real live presentation, not this walkthrough, was probably 9 major chapters, 9 major exhibits, starting with R1. That's exactly what it was. But we first got consensus from the finance team, from the executive team. These are legit. They understand what they are. And then for each one, we explain to them, here's how we're going to measure the impact of the optimization model over the status quo. So this is, once again, redacted a bit, but these were actual savings numbers that we found. And a couple of things I want to say about this. So the blue bar looks like, okay, great. So we're talking about savings. Wow, that's a wide range. 3 million to 14 million a year. How precise is your model here? And I wanted to point out that what makes this work in this circumstance, and one of the things that helped us to convince executives was, in their view, and they are right, there is a colossal amount of variability in their business, which um, they have real difficulty in seeing coming ahead of time. So in this transportation business, trucking business, their term is loose markets and tight markets. So loose markets are markets where there's not a lot of demand, and tight markets are where there's a lot of excess demand. So the bottom line is, during loose markets, they try to keep their doors open. And during tight markets, that's where all their volume is. So think about a restaurant. On the weekends, a popular restaurant, maybe on Friday and Saturday nights, tight. Really, every table gets booked up and people are calling and being turned away. Maybe during the week, half the restaurant, three-quarters of the restaurant's empty. So to show a benefit case, one of the questions they would ask us is, are you just taking the peak part of the market, or how are you thinking about this? And so part of the modeling required doing a scenario-driven approach and benefits that showed, um, uh, here are different assumptions. And the most pessimistic assumption is loose all year long, and the tight never comes. Um, Maybe that's where the $3 million benefit came from. Another analysis would say, what's the best market conditions we've seen? We had 2 years around COVID where things were really, you couldn't get transportation, and if you could, you were paying top dollar. So maybe we'll model that, and we'll show that's a high end of savings. And so we'll say, worst to best case, pick your poison somewhere in here, but here's how we model it. And the important thing is, in our opinion, is to get C-level buy-in. You really need the modelers can be inside, but you really need impartial experts to validate the results. We like to say, don't grade your own homework, because the whole claim is built on these models, and no executive is going to want to wade in and take apart your model. But secondly, executives don't like hey, I'm smart, I work for you, trust me. I'm smart, trust me. So it's really helpful in this particular area to get impartial experts. That could be from your finance department, that can be outsiders like our firm, but someone to come in and say, we analyze the models. The models are an improvement, and we analyze the economic impact, and we believe the economic impact is correct. So it's not an audit in a hardcore way, but it's basically an outside impartial validation to say these numbers are accurate and the analysis done correctly. So basically, those are the 5 steps. You analyze the flow of information and decisions. You identify a key area or areas that you want to start with. You want to analyze the status quo. Then you build your proof of concept models, and then you create a formal business case. So that's the 5 steps. A real pleasure talking with you, and I'd like to turn now to Jerry, who will give even more details on step 4. I think resources that they've collected on how to build these proof of concept models. So thank you very much. And once again, thank you for your time. Good luck on your work, and look forward to talking with you guys more. And also, if you have any questions in the QA session, happy to take an attempt to answer them. So I'll turn this over to Jerry. And
thanks, Steve. While you're doing that, when you have 2 people working on a presentation like this together, when you're the second person, typically say something like, oh, how am I going to follow that? That was really great. But with all sincerity, that was fantastic. I learned a lot, even though I knew your slides and we've spoken a lot. I think it was super helpful and very informative. So thank you for your time. And definitely I recommend to everyone to start asking questions, and we'll get to them. So I'm going to talk about something that Steve briefly mentioned. Here we go. All right. Actually, before I get into that, I'll just give a quick introduction to myself a little bit more. I'm Jerry Urchison, a data science strategist at Gurobi Optimization. So my role at Gurobi is to help connect data scientists data practitioners in the broader AI community to optimization. And so what I'm going to start talking about is the impact of optimization. This is something that Steve just sort of mentioned at his last couple slides. So as Steve mentioned, getting a neutral opinion on the benefits of a project and being able to quantify the results and the improvements and the impact is very important to sort of, again, sort of claiming success at the end. So that's precisely what we at Gurobi did. We wanted to help arm people with the information to make the business case for mathematical optimization. So through that, we commissioned a study through Forrester to look, for them to sort of ask questions to our customers and to put together essentially the impact of optimization and how it changed their business and the benefits that they have. So I'm going to quickly go over a few of the highlights from that study, and then dive into where you can get more of that information, get to the resources that we can provide to help you, again, communicate internally and externally the benefits of optimization. So a couple of the highlights again, this was through interviewing a few customers of ours, and these are larger customers, but I'll be able to show you where you can sort of get some of these numbers for yourself based off of your individual company. So there was an average return on investment, again, sort of what are you investing money into this, into Gurobi and expertise to drive these projects. What type of return do I get? So they found an average of 518% ROI with some net benefits of $4.3 million over a 3-year period and NPV of 3.6. So those are some pretty big numbers, and obviously great to see in order to make the case for optimization. But the top one I really like, and also the bottom one I really like, is when am I going to start sort of a lot of analyses and decisions about whether I'm going to take on a project or work through something is when am I going to sort of break even through these projects from our customers. They average sort of payback for the investment in just under 6 months. So some really great ways to communicate the impact of optimization. So there are also some benefits that came through this study that really weren't quantified, but are definitely worth highlighting. And this is from benefits of using Gurobi from a few of our customers, is that the Gurobi optimizer provides sort of faster solving. So this is going to help you get the decisions that you need by the time that you need them, and also at maybe the level of granularity that you need as well. Steve was mentioning how some simple decisions actually have a bunch of really smaller decisions, but a lot of stuff sort of underneath the hood there. Having a faster, more powerful solver is something that can help you get the granularity you need and be able to maybe improve to something that's maybe close to more real-time decision making and things like that could be very important to your optimization use case. The customers always also mentioned that the Gurobi solver was more robust and dependable. So less errors, more reliability, just having the confidence that if you need your decisions by 8 a.m. in order to plan for the day, then it'll be there. Or if you need decisions at 8 a.m., 9 a.m., 10 a.m. to plan for the next hour, that they'll be there when you need it. Or if you need them even 15 minutes or a minute or less than that, whatever you need, can't promise everything, but comparing Gurobi to other alternatives, this was definitely the case. We also have strong technical support and account relationships. So we have 2 of our members of our expert team here today to help answer questions. Thank you again for taking the time. But we definitely have a world-class team and to help you work through your optimization problems. And I do want to mention that they used to be called our support team, but after we realized that was just not the best way to describe this sort of all-star team. They're there to help you, through the whole process, understanding, from installation to debugging and tuning and things like that. They're going to be there to help. And we also have dedicated account representatives, both on the technical side and more on the helping you understand your licenses and everything to make sure that you're getting the most out of your Gurobi license. And then we're also sort of in the vein of having a world-class expert team. We also have a phenomenal research and development team, and we're always looking for ways to continually improve our product. One of the misconceptions that you may see or hear about mathematical optimization is that it's sort of plateauing, and there's not really too much more to do in terms of improving the product, improving the solver. And one thing that we've shown year over year is substantial improvements in our solving time and reliability and everything like that. And we also take into consideration how to deploy your model, and so whatever way you need to, we have an option that'll probably suit your needs. So we're always looking to get optimization into the hands of as many people as possible to solve as many problems as possible. So let's get into some of the resources that you can use in order to help quantify to help understand and build a case for optimization. And these are a few resources to help you understand the value of optimization and help you communicate it internally. And the first is the study that I just mentioned at the top. You can get access to the full study, an infographic that sort of summarizes the results in essentially a one pager. And then and those resources can be found at groby.com/Forrester-TEI. So a super simple URL to remember. And we also have through initiative asked Forrester to help build us a TEI calculator. So if you put in some small bits of information about your business, nothing too much. I think it's about 5 or 6 questions. So it'll help you get an understanding of how optimization can benefit your business, and it's super easy to use. I put a QR code here to if you want to scan it now and sort of get it going on your phone, you can do that. The web interface for it and mobile is quite good. Or if you want to bookmark it and dive in a little bit later, you can definitely see how optimization can help impact your business. I will say that this calculator was built again around the study that was done, and these were sort of slightly larger businesses, so you may have to do a smidge of extrapolating, but again, it can help you really understand the impacts that optimization can have on your projects. Again, for more on building the case for optimization, this is content that can help you understand applications of optimization. So who's using it, how are they using it, the complexity of those applications, and essentially how to set a path forward for you to be able to learn how to use this, how to build a skill set, and go from there. We understand that not everyone has a super math background or things like that. So we've definitely taken some time to build these types of resources for newbies to optimization, for people who are just getting started. First thing I want to highlight is our set of case studies. So you can see the numerous amounts of industries that use optimization. I think we say that between 40 and 50 different industries. We have a bunch of different customers. So optimization is all over the place, and so is Gurobi. So you can take a look at our case studies just to sort of see how this would this could fit into your industry, into your problem solving. So there's a nice URL there as well to dive into those case studies. If you want to explain mathematical optimization, it's not an easy thing to do. I still have some some troubles sort of really getting into the right level of explanation for a particular audience, but we've put together a great set of resources to help you explain what mathematical optimization is at a very high level, and also to sort of see the complexity of it, and that sometimes decision making, again, may seem very simple, but when you get down to it, it's actually very, very complicated. So we have a set of explainer videos. I think we have one published now, and we're coming out with one that the explainer video we have is a very high level description of mathematical optimization, and we'll be planning on releasing more that target an operations research crowd, a data science crowd, and a C-suite crowd as well. So whatever audience you're looking for to explain optimization to, there's something that you can use from us to help. And actually, I think I put a QR code for that as well, so you can scan that too, and it'll take you to a YouTube video that we published for that first explainer video. The other thing I want to mention is an awesome game that we put together. And whenever you can gamify anything, I think that really helps people understand. It's called the Burrito Optimization Game. And essentially, it takes you through a very simple sort of game where you have simple decisions of where to put burrito trucks on a map and how many of them to put out there in order to feed people for lunch. That's it. That's the problem. But the number of possibilities that you have are actually very, very, very high. The number of combinations that you can use is exceptionally high, and sort of shows the complexity of a very simple problem. But in reality, in order to get an optimal decision, an optimal result, it's actually very complicated. So it's a great way to introduce the complexity of optimization as well. And we also have a bunch of other educational resources. You're tuned into one right now. Lots of webinars on a bunch of different topics, ranging from particular features to just to things like this, where it's broader business cases. We have a webinar that can help you tackle pretty much any problem. And again, a lot of our technical folks have put in a lot of effort to make these things exceptionally easily accessed. So, and we also have trainings. I recently, last year, did a two half day, hands-on training for data scientists to as an introduction to optimization. That was super fun and awesome to do. But we also have a lot of other training methods and resources out there as well, so you can really get your hands on optimization. And then for maybe shorter sessions there, we have notebook and coding examples to help you learn whatever you need to do, Jupyter modeling examples and functional code examples all over the place. So you can check out a lot of this stuff, including the optimization game, at growy.com/learn. So many resources to help you get going. And then lastly, some resources again that are similar to the case studies, but from Informs. And Steve mentioned that he's been involved with that organization, and it is like essentially the premier organization for operations research and management science. And they give out an award annually. And you can see like the high impact projects that people are using optimization for, with actual measurables for financial and social impact. So I really highly recommend that you check out that website as well to see, again, how people are using optimization. So the last bit of information that or the topic I want to hit on is what about open source? And one reason I wanted to highlight this is because when you're making the case for optimization, and particularly and making a case for anything in an analytics field, cost is an issue, and open source sort of alleviates some of that. So it's undoubtedly a question that you're going to have to address, I think, at some point when you're making the case for optimization. So first off, open source software and packages, they are a key driver, a key reason why data and analytics projects have taken off. And I think you probably know why, because they are easy to access. If you're a Python user, just pip installing something, and there you go. You have access to deep learning in an instant. That's really, really powerful stuff. They have a large user base, so if you do run into problems, hopefully someone has run into the same problem as you have. If they did, then great. You may have a solution to sort of fix some bugs. But the most important thing that people are particularly when making the case for optimization or any other projects is, hey, open source is free. That's great. But I want to highlight sort of why open source is very much used for machine learning and data science projects, but not it's not always the go-to thing for optimization. And it sort of relies or revolves around what those two problems are doing fundamentally. And a machine learning project, essentially the goal of that is it's to find parameters of some type of model, but it's to find the parameters that fit the data. So in essence, data is the important part. Data is the thing that is crucial. to this, and from like more of like an algorithmic perspective, things like the algorithms that are used to sort of solve these things are complex, but not the most complex things that exist out there. So it's easy to share and put these things out there. But again, data is at the center there. For a mathematical optimization project, it uses a model that you would create to optimally solve a problem, to find that optimal solution. So the key there is in the solving of that problem. So it's sort of this. I wanted to highlight this because it shows the difference of where sort of the value is of what you need to have going into these projects. You need data for a machine learning project, and you need to be able to have the skill set and everything, obviously, to deal with that. But it's, again, focused around the data, and mathematical optimization is focused around the solving. So the solver is a key component when you're tackling some of these projects. So there is a bit of a difference there. And the important thing is you need to find a solution that meets your needs when it comes to scaling optimization projects, or addressing all of those things that I was talking about a few slides ago with customer sentiment about Gurobi. Some of those things may be exceptionally important to you and your project, and open source sort of solvers may not be able to meet those needs. So again, you just need to find the right solution. You need to find what works best for your problem and everything. So I think that's it for me. Again, thank you very much for your time.
I just want to thank everybody for joining us today. And a special thank you to Steve and Jerry for the presentation.